Okay, so question 2 of your paper February-March 2024 variant 2 says that the diagram shows the curve with equation y is equals to k times sine of half x, where k is a positive constant and x is measured in radians. The curve has a minimum point at A. State the coordinates of A. Okay, the coordinates of A will be not too difficult. Okay, there are many ways of doing it. First, we need to understand what is represented by each thing in this equation. As we know, the graph of a sine curve, that you have y is equals to, the general form is y is equals to a sine bx plus c, where this a represents the amplitude, okay, and this b represents the cycles or the frequency. Okay, so looking into this k represents your amplitude, so that means that this is going to be your positive k and this will be your negative k. Okay, then half, what does this half represents? This half is representing that the frequency, the number of cycles, so that represents that half the cycle will be in your 360 degrees range. Okay, so half the cycle means this much, half the cycle is 360. So what will be your full cycle in? So your full complete cycle would be in 720. So that means this point, this curve from here to here, we are having here to be 720. Okay, but they have measured it in radians, so this is 2 pi, 360 is 2 pi and 720 is 4 pi. So that means your this position is 4 pi. Okay, half of it, half of the cycle is here, that is 2 pi. Then what will be in between here at this point? This must be then 3 pi. Okay, and from this all we can conclude that your x coordinate to be 3 pi and your y coordinate of this a point to be minus k. So you can state that a is 3 pi and minus k, like this. Okay, this is one way of doing it. Another way of doing it is that we know the formula of period. Period is 2 pi over b. B is again the same, the cycles which are represented with the x variable. Okay, so 2 pi over half is going to be equals to 4 pi. So this also gives you that how much this whole curve is having, like what is the period of one cycle. So from here you can also get this. So when you get how you get this 4 pi, you can easily figure out where this a point is. Okay, so this is how you can do it. Okay, now part B. Part B says that a sequence of transformations is applied to the curve in the following order. Translation of 2 units in the negative y direction. Okay, negative y direction means it is going to be shifted 2 units down. So when it is 2 units down, that means your translation vector would be 0 and minus 2. Okay, so this is going to be your first transformation. The second is the reflection in the x-axis. So whenever your curve or any curve, any line is reflected in your x-axis, then from here it is reflected here. So that means its y coordinate becomes negative. So what do we do in that case? We always, when we have reflection in x-axis, we multiply y by 1, minus 1. Multiply y by minus 1. Okay, so this is how we will, this is the set of transformations, and now let's apply it on the equation. Okay, so what is the equation of the curve? Y is equals to k sine half x. So first thing is the translation in the negative y direction, 2 units. So that means y minus 2. Something is being subtracted from the y coordinate to get it in the negative y direction. So it will become k sine of 1 by 2x minus 2. The whole y minus 2. Okay, this is first thing. Then the second is the reflection in x-axis. So multiply y by minus 1. So that means here this whole will be multiplied by minus 1, or you may call this to be as y prime or y dash, like we have already done y minus 2. Now y double dash would be just, it's not a prime thing, it's just to differentiate between the y's. So it will become y minus of y. So it will become minus of k sine half x minus 2. So it will become minus k sine 1 by 2x plus 2. This is how your new equation after this applying two sets of transformations will be.